Welcome back to another installment of Mattea Valley Calculus. Today I'll be explaining to you geometric sequences and series. So first you need to ask yourself, what's the difference between a sequence and a series? Well, a sequence is merely a list of terms. So 1, 1, 1, 1 would be a sequence. A series is when you add up a list of terms, or the sequence of terms. So that would be 1 plus 1 plus 1 plus 1. Which would be 4. So that would be the series of the sequence. Now, in terms of a geometric sequence and series, you always have something called a common ratio. So if we take the example 1/3 to the n, then the sequence of this would be 1/3, 1/3 squared, 1/3 cubed, 1/3 to the fourth. Dot, dot, dot. So it would basically be 1/3 to the n. Now, the main question with geometric series is, does it converge? The way you tell if it converges is if this term right here, the common ratio, or the thing that's constantly being put to a new power, is that less than 1 or greater than -1? You always need to ask yourself that. So obviously this is less than 1, but it's greater than -1. So we know that in this case, this geometric series converges. So we can either find the convergence for the first 4 terms, or we can find it for the infinite amount of terms. So let's say, we want to find it for the first 4 terms. Then we would use this formula. So s to the n is equal to a times 1 minus r to the n all over 1 minus r. Now, the a is simply the first term, and the r is the common ratio. So here we know that the first term for this sequence that we found before is 1/3, and the common ratio is also 1/3. So if we want to find the series of the first 4 terms, it would be equal to the first term, which is 1/3, times 1 minus, and then the common ratio, which is also 1/3, to the fourth, because that's the number that we're trying to find, all over 1 minus 1/3. And after simplification, this comes out to 40 over 81. Now, that's easy enough for the first 4 terms, but if you're curious about how it goes as the limit goes to infinity of that certain ratio of 1/3 to the n, then you would use a different formula, and that is that as it approaches infinity, it's equal to the first term over 1 minus the common ratio. It's even simpler than the last formula. So we would simply just plug in numbers here. So it would be 1/3 minus 1 over 1/3, which is just 1/3, 1/2. That would be the sum as 1/3 to the n, the summation of this from n equals 0 to infinity. That's basically all a geometric series is.